Explain question number 4, exercise 7.8, class 12th. Find integration 1 to 4 bracket of x square minus x dx as the limit of a sum. Solution start. By definition, integration of a to b f of x dx is equal to bracket of b minus a limit n tends to infinite 1 upon n bracket of f of a plus h plus dash 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 plus f of a plus n minus 1 into h, where h is equal to b minus a upon n. Here compare given integration 1 to 4 bracket of x square minus x dx with the standard form of definition integration a to b f of x dx given by a is equal to 1, b is equal to 4, f of x is equal to x square minus x, h is equal to 4 minus 1 upon n is equal to 3 by n. Therefore, integration of 1 to 4 bracket of x square minus x dx is equal to, put these values in the standard form of definitions. So 4 minus 1 limit n tends to infinite 1 upon n bracket of f of 1 plus f of 1 plus h plus f of 1 plus 2h plus dash 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 plus f of 1 plus n minus 1 into h. Put the value for find the f of 1 values. Put x value is 1, so 1 square is 1 minus 1 is 0, and f of 1 plus h means x value put 1 plus h, so 1 plus h whole square minus 1 plus h, and this way to express all terms, so is equal to 3. Limit 4 minus 1 is 3, limit n tends to infinite 1 upon n bracket 0 plus bracket of bracket 1 plus h whole square minus bracket of 1 plus h plus bracket of bracket 1 plus 2h whole square minus bracket of 1 plus 2h plus dash 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 plus bracket of bracket 1 plus n minus 1 into h whole square minus bracket of 1 plus n minus 1 into h. So is equal to limit n tends to infinite 1 upon n bracket of bracket. Here 1 plus h whole square is open, so 1 plus h square plus 2h and minus inside the bracket, so minus 1 minus h plus bracket of here 1 plus 2h whole square open, so 1 plus 4h square plus 4h minus multiply inside, so minus 1 minus 2h plus dash dash so on plus bracket of 1 plus n minus 1 into h whole square open, so 1 plus n minus 1 whole square h square plus 2 into n minus 1 into h, and minus 1 multiply inside, so minus 1 minus of n minus 1 into h. So here is equal to 3 limit n tends to infinite 1 upon n bracket of here minus 1 to 1 minus 1 cancel and 2h minus 1 is h, so bracket of h square plus h plus here 1 to 1 cancel and 2h 4h minus 2h is 2h, so 2h whole square plus 2h plus dash 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 plus bracket of here 1 to 1 cancel and 2n minus 1 into h minus of n minus 1 into h, so remaining is n minus 1 into h, so we break it off n minus 1 whole square h square plus n minus 1 into h. Here is equal to 3 limit n tends to infinite 1 upon n bracket. In all h square terms take common, h square is common, so bracket of 1 plus 1 square plus 2 square plus dash 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 plus bracket of n minus 1 square, and in all h terms h take common, so plus of h bracket 1 plus 2 plus dash 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 plus bracket of n minus 1. Here 1 square plus 2 square plus dash dash n minus 1 whole square, this sum is n minus 1 into n into 2n minus 1 by 6, and 1 to n minus 1 sum is n minus 1 into n by 2, so is equal to 3 limit n tends to infinite 1 upon n bracket of h square bracket n minus 1 into n into 2n minus 1 by 6 plus h bracket of n minus 1 into n by 2. Here n minus 1 multiply to n and here n minus 1 multiply to n, so is equal to 3 limit n tends to infinite 1 upon n h square bracket of n square minus n into 2n minus 1 by 6 plus h into bracket of n square minus n by 2. Here put h square value, because here put h values in these two terms, so h value is 3 by n, so and 1 upon n multiply inside the bracket, so is equal to 3 limit n tends to infinite h square means 3 by n whole square is 9 by n square and 1 upon n multiply inside, so 9 upon n cube, and n square minus n multiplied to 2n minus 1 is 2n cube minus 3n square plus n by 6 plus h value is 3 by n and 1 upon n multiply. So 3 upon n square bracket of n square minus n by 2. In this term take 6 outside common and this term take 2 outside common, and in this term n cube is divided inside the bracket and this term n square divided the bracket inside the bracket, so it's equal to 3 limit n tends to infinite bracket of 9 by 6 bracket 1 upon n cube multiply inside the bracket, so 2 minus 3 upon n plus 1 upon n square plus 3 by 2 because 2 took outside common and n square multiply inside 1 upon n square, so is equal to bracket of 1 minus 1 upon n. Put the limit value and tends to infinite inside the brackets, so 3 bracket of 3 by 2 9 by 6 is 3 by 2 bracket of 2 minus 0 plus 0, this is 0, this is 0 plus 3 by 2 and this is 1, so bracket 1 and this is 0, so minus 0. So 3 by 2 multiply to 2 is 3 and here 3 by 2 multiply to 1 is 3 by 2, so is equal to 3 bracket of 3 plus 3 by 2 and 3 plus 3 by 2 is 9 by 2 multiplied to 3 is equal to 27 by 2. That is the solution of the question.